Hello friends, welcome back to my channel. Today we are going to talk about Snowflake Streams. Not before today, but whenever Snowflake started, before that, we used to use additional columns into the table to change data capture. So whenever we wanted to capture what are the DML operations happen on the traditional tables into traditional databases, then we always used to add additional column like similar timestamps or maybe numbering system. So suppose we have already processed the data. Suppose there is web application which is getting orders, which is e-commerce application, and you're getting a lot of orders and you want to process and do some real-time analytics. So what you used to do, you were having another application which is data analytics application, which is reading data from your orders table. But how it understands that last orders we already processed and what are the new orders, what are the updated orders. So for that we have additional column into the orders table which we added for specifically for that purpose. So now you just run the select query based on that additional column filter, right? So that was little bit cumbersome and still it was working. But Snowflake has come up with very not traditional, it's a very sophisticated solution where you can just create an object on the table and you can use that stream object just to get whatever the data differences happen into that table. Okay, so whatever DML operations happen, you will get that into the stream object and you can just process them. So let's understand whatever everything is about Snowflake Stream in this video. Okay, so let's get started. So first of all, what is stream? As I already mentioned, it is a change data capture system that tracks changes to data in Snowflake tables. In fact, not only tables, it also works on Iceberg tables, then external tables and directory table. So that can also be used here. And how it is helpful? So as it is capturing changes, it will allow you to do some real-time analytics and data processing. So you can write a lot of data pipelines based on your data, based on your requirements, because this is going to be very useful feature in your data pipelines. Okay, actually it is going to be an integral part of your data pipelines. So let's understand how the stream works. So to check that, you have to see this image, and as you can see, this is horizontal line which is nothing but a timeline of the table. So whenever you create a table, there is a versioning system is managed by Snowflake itself. So you create a table, you have added some data, it will keep adding versions based on whenever you commit changes, the new version will be created. And what is the new version? It's just kind of a snapshot, you can say, right? And as you can see here in this image, V0 was the first version, then V1, V2, V3. And when you were at V3 version and you created a stream on top of the table. So when you create the stream on the table, stream also has an offset value, and it understands that offset value will be set at V3. Okay, and now you make some operations on that DML operations on that table, or you add some files onto the stage which is called directory table, then it will start adding a new versions. Snowflake will start adding new versions basically. So as you can see here, let me show you. So as you can see here, yeah, so this is V4, then it is keep adding versions V5, V6, V7, V8 and V10. So until V10 you have not consumed that stream, and that's why it is showing this whole timeline which is captured by that stream. Okay, and the stream name is S1 here. So whenever you try to consume at V10 level, you will get whatever data are inserted or modified between this V3 and V10 snapshots. So V4 and V10 will be included. Okay, so that's how this stream works. Let's go further and check how we can create the stream basically. So as you can see, this is first statement, which is very simple, right? It is very easy to create a stream. Create stream name on table and whatever the table name you want to use. Okay, so this will create a stream where it will give you all the details, all the DML operations like insert, update and delete. But suppose you just want to get only insert only records, then you can use this flag also. Okay, so append only is equal to true. Okay, now suppose you are having one external table, not internal table, not standard table, or not even Snowflake managed Iceberg table. Suppose there are two tables. One is Iceberg, which is managed by external resources, external catalog, and then there is external table, which is also an external table. A lot of external F1s here. So anyways, but you can create insert only stream on the external tables, but the syntax stays the same. Okay, table and then table name, because Snowflake understands this table is what type, right? So Snowflake understands and it will create the string accordingly. Now if you go and check this particular syntax where it's a different on stage, it's not on table. So basically you can create the stream on table as well, sorry, stage as well, and stage is considered as a directed table. So basically it's a file system, right? It has a lot of files loaded, and when you load the files or you add the new file, Snowflake knows that, in fact stream knows that there is a new file came in. So whenever you use that stream, you will get the list of new files added. Okay, so that's how it is also useful. Okay, now can we clone the stream similar to other objects? Yes, you can clone the stream, and the syntax is very similar to other objects. Create stream, stream name, and you can just use clone and whatever stream name you want to clone. Okay, it's very simple. So when you clone the stream, right, so at that moment stream has already some captured data, then the clone stream will also have the same data. So that way you can use the clone stream. So what are the objects are supported to create streams? So as you looked at it, right, tables and views. So what are the tables are supported? So first is standard. Standard table means whenever you just create table and whatever table name you give, right, transient, temporary table, and the main table, right? So these are the standard tables. What is directed table? It's nothing but stage. So when you create an internal stage or external stage, right, just storage is different. Internal stage means Snowflake is providing a storage, and external stage means storage is provided by external services like S3, Azure storage, and Google Cloud Storage, right? So those are the storages. Now these are other table types like dynamic table, event table, external table, and Iceberg table. Okay, so these all tables are supported to create streams. Now what about views? So views is also similar. I mean, when you talk about standard views, it always is just a view. It's a wrapper function, you can say, right? So when you use that, it always directly read the data from table. So basically underlined tables will be used. So yes, so standard views are supported, secure views are also supported, materialized views also supported to create a stream on that. We'll take a look on this all, not all, but at least most of them into the demo. Okay, so stay tuned for that. So what is staleness in streams? So there is a concept of staleness. Staleness means, so whenever stream has some retention period, basically you can provide a retention period maximum of 14 days. Okay, so whenever suppose you have provided retention period is 2 days, and if you are trying to use that stream, and sometimes your task is failing, and because of that stream was not used for a couple of days, and on the third day the stream became stale. If you do not want stream to be a stale, then you have to use before retention period ends. Okay, so you can see those details in stream details, like using this couple of command, describe stream my stream and show streams like my stream. So what are the limitations? So limitations are very few, but still you have to know, like external table and Iceberg table with external catalog supports only insert only streams. You cannot use you cannot have update operations capture into your stream. Okay, so this is the one limitation. And suppose you have a view which has union all, with the same table or a clone table or any other table, then it is not supported. Okay, then there is a third limitation, which is you cannot track changes on a view which is having a group by statement inside that. So suppose you have a query group with group by and you are building a view based on that group by query, then on top of that view, stream is not supported. Okay, so yeah, so first of all we will see how we can create the streams on tables. So we are going to create a database demo, but I think database is already created, so it won't work. So I have prepared 4 sheets, so I will go one by one. Now as you can see, I am creating a table called users. Then I will create a stream on the users. So look at the syntax: create or replace stream, user stream on tables users, right? So you can also have to provide fully qualified name if you are trying to create a stream in this schema, but table is on different schema or different database, then you have to give fully qualified name like database name dot schema name dot users. Okay, so as we are already having this data, I mean this table inside this stream, this schema, then you do not need to provide this fully qualified name. So I'll create the stream now. So as you can see, let me before I'll add one more syntax here. Select star from users and look at the columns. There are 3 columns, but if you check the same way from the stream, you will see additional 3 columns. One is action, metadata action, metadata is update, and metadata row ID. So those 3 columns can be used when you are consuming the stream. And yeah, so we'll look at that. I am creating another table called registration, which is having 2 columns, ID and rdate. So ID is nothing but user's ID. So we are going to use it while joining the data. Now insert into users, I am just going to insert 5 records here. And now I am again inserting 5 records in registration tables. Now if you see, if you check the stream, it will have 5 records because we inserted 5 records. And look at the 3 columns where action is insert for all. This was not an update operation, it was insert operation, so that's why it is false. And these are the row ID. So row ID for each row. Okay, so that can be also used in many cases, but for now we will ignore it because we are not going to use it right now. But this is identifier for this row, as you can see, right? Now I am just going to use merge statement wherever. So this is just to update the records. Okay, so I am just trying to update the charges for whatever registration happened in last 1 month. Okay, so 1 record was updated. Now if you see, select star from users, 1 record has been updated by charges 150. Now if you see this stream, it will have 5 records of inserted, but there is no extra record for update and anything, right? There is other operation. So as we saw in that image, right, that version was 1 v0, and then right now we did couple of DML operations, but still we are getting those 5 records as insert. Why? Because we actually inserted, and for the target audience, not consumers, they do not know what happened between those 2 transactions, right? First we inserted, then we updated, but still for consumer this record is only inserted, right? There is no need to know if it is updated or not. And if you want to capture that as well, then you probably have to consume it very quickly. So that's how you can do it. So now I'm just going to create a table called users processed, because we are going to insert the records into this table using the stream. Now I'm going to insert the first batch of stream data into the production table, not production, processed table. So the statement for that is insert into this processed table. These are the 3 columns, and then you can pass the select statement instead of values. And if you see here, I added this particular where condition. If I do not do that right now, that will be okay, because all the records are insert statement. So I'll just insert it, and if you see 5 records are inserted into this. Now once the any DML operation suppose happens as part of the transaction where the stream is used, then stream becomes automatically empty. Look at this, right? All right, now what happens inside the transaction? So suppose let's start one transaction here, and we'll make some DML operations like updating the users table. I'll just update the charges to charges plus 100 wherever the charges is 0. Okay, now if you see the select star from users, you will see that 100 is updated for all other records which was having 0 charges, but stream will not have anything. Why? Because the transaction is not committed. So once the transaction is committed, then and only stream will understand that these are the changes came into the database, into the table. Right, now let me commit the changes and now check the stream. It will show you 8 operations. So one more thing you need to understand is that how Snowflake performs update operation. So basically they delete the old operation, old record, and insert the new record. So that's how it does that, right? But how do you know that this was updated? So to do that, you can look at this. Action is insert, but the is update is true. So this insert was happened as part of the update operation. So basically when you are consuming the stream, right? So you know that you can ignore this delete operations. Okay, probably when the is update is true, and you can use this insert records and just check that if it is updated or not. If it is updated, then probably you can process that way. So these are the metadata you can use to further processing. Okay, now another thing I would like to showcase, that is when the stream is consumed inside the transaction itself. Okay, so there are a couple of use cases. So suppose you are writing a task which is basically inside the transaction. Let me go into transaction. I am creating one temporary table from the stream. So what is the syntax? Create temporary table name, and as select query. So basically it is creating a table from the data consumed from the stream. Okay, so again it's a DML operations. So stream should have been blanked. Select star, sorry. Alright, so let's start from user stream. So as you can see, this temporary table is created, and now if you check the stream won't have any data. Why? Because it's consumed by this create statement. And now if I create the table, new table, so again I've just missed a star here, and if you try to consume again by create table, and if you commit it, and now let's check all the tables. First I will check stream. Okay, sorry, again star is missing. Stream doesn't have any data. Consumer 1 will have 5 records, not 5 actually, because we tried to insert without any filter conditions, right? I should have added filter condition called metadata action is equal to insert, but I did not. So it's okay, right? We just want to understand concept of using streams multiple times in a transaction. Alright, so consumer 1 has the data, but consumer 2 won't have any data because stream was empty once it was used in create statement. But there is another use case, how if you are using insert statement. So again I will go back into begin statement, and okay, so first of all we have to get user stream filled in, right? So right now just user streams have nothing, right? So what I'll do is I'll use this query, I will add here, and wherever charges are 100 I will add more 100. So basically I am updating 4 records again, and now if I check this transaction and if I do this insert statement, oh sorry, actually I started one transaction and then I did that, right? So that's wrong. Start again begin statement. I will check the stream. If you see, the stream has 8 records, 4 are for deleting old records, and 4 are for inserting new records. Okay. Now I will just go and use insert statement, and I am going to add the same records in consumer 1 table. So probably it will have 16 records because 8 were earlier we inserted using this create statement, and now again 8 we inserted. Now if you check the stream, so this is magic. Look at this, stream still have the data because we consume this stream as part of the insert statement, not part of the create statement. So this is how stream behaves actually. So that's how Snowflake has built the stream. Now if I do the again insert statement using the same stream, this time it will again insert the 8 records. But if I commit this transaction, then stream becomes empty. Look at the stream now. Okay, stream is empty. Consumer 1 will have 16 records, but this time we do not have this one because we used insert statement, and where we did not consider those 3 columns, and based on that the all values are null here. Now check the consumer 2, it will have again the same 8 records. So this is how you can use the stream on table. Now let's look at the staleness again. Describe stream and the stream name. So if you do this, you will see there are a lot of tables. Actually you can consider all those things. When it stream was created, what was the name, what is the name of the stream, what is the database name, schema name, owner, who created it actually, and on what table we are using the stream. So users, source type is table, it can be a view also. Base table is nothing but suppose you have used view, then table name will be displayed as view, source type will be view, and base table will be again based on that. Type is delta, stale is false, so right now the stream is not staled. Mode is default, mode is nothing but append only mode, so those are the modes, append only stream, right? Stale after, so as you can see after 15th of September, so as I mentioned, right, so 14 days is the maximum retention period, and that is default one also. So after 15th of September it will be stale if I don't use even a single time. So suppose if I use the stream after this, then again it will change that stale after value from that point to plus 14 days, right? So that's how this is behave. So there is no reason for becoming stale right now. So yeah, so that's pretty much from this streams on table. Now let's go into streams on views. So again I'll use the same database, same stream schema, and I'm just going to create a view which is very simple. Okay, now create stream on this view. The syntax is little different, called like this. Let me run this. So it will create a stream. Let's describe this stream. So what are the differences we see here when we create the stream on view? So all details are same, but as you can see table name is demo.usersView, source type is view, but base tables. So suppose there is a view which will see that actually. I'll show you that. So when we use multiple tables in the view, then it will show the multiple tables here. So type is delta, all is the same. All details are similar, right? Now what I'll do is I'll insert couple of records here. So at least we will have something to see in the stream. Now before taking a look into the stream, I would like to create a batch table because I want to show you the join between two tables and create a view, right? So that is another way. Now I am inserting 8 badges for this 11 and 12 ID of user. So as you can see, this is a user ID, second column. For 12th user there are 4 badges, but for 11th user only 2 badges. So I will insert it. Okay, so I have inserted them, and I will just check users view stream. So as you can see, we added couple of records here, and that's why we see 2 changes here, right? Now this is very simple, as very similar to the streams we saw in tables, but what happens if we have join into that view, right? So what I'm doing is here I'm creating a view, badges view, which is actually joining two tables, badges and users. So what I am trying to do here is that, so let me show you that. I'll create a view and let me see the data. So data looks like that, username and badges. So there are 6 users, only 2 users with 6 badges total, right? Now I am creating a stream on this badges view. So I'll call it badges view stream. And now if I see the stream, again same concept, 3 columns will be added. And now I am trying to update a user which is having ID 12 to U12 updated. So basically when we update the record, what happens is that delete operations and insert operations, right? Now let's take a look on the data. You will see magic here. So instead of 2 records, you will see 8 records. Why? Because there is a join operation between badges and users. We updated one user called 12th one, this one, right? So when you join between user and badges table, you have 4 records actually. And because of that 4 records, whenever you update this record, you are trying to update 4 records in the view. And as we are uploading 4 records, we will have 4 plus 4 is 8 records into the stream. So older record was like this, U12 silver, and now the new one is U12 updated silver, right? So that's you have to consider, I mean, whenever you are trying to create a stream on the view. Okay, so this is very helpful actually. So let me create a temporary table. All right. So now the stream is consumed. So that is blank. Now again, if I insert a users, I consumed it, now stream is blank, but I am adding a new user with the same ID, but the username is different. So this is just an example, so you can just forget the other concepts like what is the primary key, this is the identifier of this user. So what will happen? Look at this, another 4 records actually. New U12 silver, new U12 bronze. So now if you see the view, so there are 8 badges for the same user. It's a 2 different user, but both are having same ID, that's why. Okay, so that was streams on views. Now let's talk about streams on stage. So again, I'll just use this TB and schema. I'll create a stage, create or replace stage like this. Stage is created. Now how can you check how many files are there into particular table or stage? Just directly select star directory. This is the syntax you can use, right? So because it's a directory table, so you can use directory, and inside that you have to pass stage name @stage. So as you can see, there is no file available right now into this cricket matches, but let me create a stream also. Okay, stream is created. So now stream will also have the similar information with additional 3 columns. Now what I'll do here is I'll go to the streams demo schema, then stages, and I will open this in the new tab, and I'll change, and I'll add a new file. This 4 files I'll add, and I'll upload. So all files are uploaded now, and if you see the stream, now you will see 4 files available here. So what happens is that, suppose you have some AI workflow where there are new documents are coming every day, someone is uploading, and you have to read that one by one. Whenever new file comes in, you just want to add that content of that particular document as a knowledge base into any AI model, then you can use this stream. Okay, so how can you read that? So you know that how to read the files. So this is the complete path of that file. So basically you can look at this here. So this is a relative path and this is a stage name. So when you give this relative path after this, let me change it to this 17, and if I do this $1, you will get the whole JSON content. Okay, so this is how you can run the stream on this, right? Now the final one is I will talk about streams on Iceberg table, so which is very similar to this standard table, but only that is storage is outside of Snowflake. So basically storage is S3. I have pre-configured it right now because I do not want to spend time on this, how we can create external Iceberg table. I will create another video for this. So yeah, so this is created, and let me describe it. Let me see if user ARN is changed. I'll just copy it for now, and I'll try to create Iceberg table. Iceberg table is created where we provide this external volume. Okay, and I'll just take a look if records are exist or not. Now you can create the stream. You insert the records. 3 records will be inserted. Then again you can see the 3 records are inserted here. So let me go to directly here. So I'm just consuming that by create statement. I'm updating the record. The stream will behave the same. And here, so what I would like to show here is that this is the Iceberg table but managed by Snowflake. So as you can see here, catalog, right, Snowflake. So same way you can create Iceberg tables with the external catalogs. So in that case you cannot create append only stream. So right now you will be able to create append only stream here, but if you are having in Iceberg table based on external catalog, then you will not be able to do that, and you have to use insert only as I mentioned in PPT, right? So that's pretty much from this video. If I haven't covered anything, if I have missed something, please write into the comment section, so I will look at that, I will respond that, and I will probably create updated video on top of that. So thank you very much for watching this video, and hit the like button if you have liked it, and subscribe my channel. Thank you very much, and see you soon in the next video.